Zig, a high-performance system programming language, often labeled as a next-generation alternative to C. It was created by Andrew Kelly in 2016, and has quickly evolved into one of the most desired new languages in the world. Like C, it's minimal, extremely fast, and allows for low-level memory control. But instead of managing memory directly in the language with functions like malloc and free, the Zig standard library ships allocators to provide a consistent interface for memory management. Zig is not a memory-safe language like Rust or Go, but it doesn't have any hidden memory allocations, making the code far more explicit and portable, because allocators can be easily swapped out in the code to target different architectures like x86, ARM, WebAssembly, and bare metal. In addition, Zig has no hidden control flow. If it looks like a function and quacks like a function, it's a function. There's no operator overloading, and it doesn't even have exceptions. If a function can fail, it needs to return an explicit error value. The language also has a unique comp time keyword that makes it trivial to run code at compile time instead of runtime. No preprocessor or macros are necessary. And finally, Zig can integrate well into a C or C++ code base and supports cross-compilation out of the box with LLVM, although divorce paperwork has been filed. To get started, install Zig, then create a new project with the zig init.exe command. In the main file, first import the standard library, then define a main function. Notice how the function returns a type of void with an exclamation point. That exclamation point means that the function might return an error. Declare a mutable variable with the var keyword, followed by a type like u8 to represent a single byte, then assign and modify its value later. Or use const to define an immutable variable that cannot be changed. We can also bundle multiple variables together into a struct, then access them on that namespace with dot notation. Now things start to get more interesting when memory management comes into play. When initializing an array of integers, we can allocate it to a slice of memory in the heap using the built-in page allocator from the standard library. What's so cool about this is that we could swap it out with other allocators to use different memory management strategies. Now when we're done with this memory, we need to set it free, otherwise we could have a memory leak. The defer keyword allows us to put that code right next to the allocation itself, and will automatically deinitialize the list when it goes out of scope. Now as we operate on the list, the try keyword provides explicit error handling. If this line fails, it will automatically catch and return the error. You can't just ignore it, and that will make your code more reliable. And speaking of reliability, Zig has a built-in testing framework. Use the test keyword to evaluate code outside of the main program, then use the zig test command to run it. And finally, build an executable with the zig build command, and choose a build mode to optimize for speed, size, or safety. This has been the Zig programming language in 100 seconds. Hit the like button if you want to see more short videos like this. Thanks for watching, and I will see you in the next one.